Hello everyone, how are you? Welcome to mathematics class for class 9. Today we are going to do chapter 14, statistics. Children, every day you come across a lot of information, be it in the form of numbers, figures, pictures, graphs, etc. But we need to analyze this information to reach a conclusion. So all these factors or figures which can be numerical or otherwise, they are called data. Now just having data is not going to serve any purpose. We need to extract information from it. So this meaningful extraction of information is studied in a branch of mathematics called statistics. Now statistics involves collection of data, organization of data, analysis of data and interpretation of data. Now let us talk about collection of data. Data is of two forms. One is primary data and another is secondary data. Let us understand with the help of an example. Now suppose a student notes down the marks obtained by him or her in maths tests throughout the year. This is in order to gauge his performance. Now here the investigator is collecting information on his own and that too for a specific purpose. So this type of data is called primary data. Now another student, he does not collect the information on his own but relies on the information that is collected by his teacher, that the record maintained by his teacher. So this kind of data which the investigator does not collect on his own is called a secondary data. So now let us see how are we going to present this data. Data can be represented in a meaningful, easily understood manner in two ways. One is ungrouped frequency distribution table and another is with the help of grouped frequency distribution table. Children, look at this data collected by a student of class 9 regarding the marks obtained by 30 students of his class in a class test. You can see that there are various numbers that can be seen. This is called raw data. This data does not tell us anything about the class performance. How much is the highest score, how much is the lowest score, or how many students have scored a particular number of marks. So we need to present it properly. Let us do it with the help of this table. Here I am going to show the marks and here the number of students who have scored the particular mark. Now you can see the minimum marks was 0. How many students have scored 0? That is only 1. Then is 0.5, that is 2. Then is 2, only one student has scored 2 marks. Then 2.5, one student has scored 2.5. Then 3, you can see that here 1, 2, 3. 3 students have scored 3 marks. Then comes 4. 1, 2, 3, 4, 5. 5 students have scored 4 marks. Then comes 4.5. 2 students have scored 4.5. Then comes 5. Clearly 3 students have scored 5 marks. Then 6. 2 students have scored 6 marks. 6.5. 1 student has scored 6.5. 7. 2 students have scored 7 marks. 7.5. 1 student has scored 7.5. 8 marks. 1 student has scored 8 marks. 9. 1 student has scored 9 marks. 9.5. 1 student has scored 9.5. And 10. 2 students have scored 10 marks. So you can see from this table that maximum value is 10 and minimum is 0. The difference between maximum and minimum value is called range. So range is equal to maximum value minus minimum value is equal to 10 minus 0 is equal to 10. Children, I have a question for you. The value of pi up to 50 decimal places is given below. Make a frequency distribution of the digits from 0 to 9 after the decimal point. What are the most and least frequently occurring digits? Children, do this on your own. Now look at this data. The heights of 50 students measured to the nearest centimeters have been found to be as follows. So children, how are we going to represent this data? Since there are 50 readings and a lot of variation, ungrouped frequency distribution table won't allow us to present this data in an effective manner. So let us present this data in a grouped manner. You can see that this data ranges from values 150 to 173. So we can group the data as 150 to 155, 155 to 160 and so on till 170 to 175. These groupings are called classes or class intervals and their size is called class size or class width. In each of these classes, the least number is called lower class limit. For example, in 150 to 155, lower class limit is 150 and upper class limit is 155. And their difference that is 155 minus 150 is equal to 5 is called class width or class size. So children, let us start with organizing this data with the help of frequency distribution table. In the first column, I am going to show height of students. In the second, tally marks, and in the third, frequency. As already discussed, we are going to write the classes as 150 to 155, 155 to 160, 160 to 165, 165 to 170 and 170 to 175. So children, if you look at your data, the first number is 161. It lies between 160 and 165. So here in front of 160 to 165, we draw this slanting line representing the tally marks. Next is 150. Now 150 will certainly come between 150 and 155. So here we draw a tally mark. Then is 154. It is also coming between 150 and 155. So another tally mark. 165. Now 165 seems to be coming both in 160 to 165 and 165 to 170. In order to remove this dilemma, we have a convention which says that we will keep 165 in 165 to 170. That is, in any class interval, the lower class limit will be a part of it, but not the upper class limit. The next reading is 168. So here we will keep it between 165 to 170. So here there is a tally mark for it. 161, it should come between 160 and 165. So tally mark will come here for it. 154 here. 162 between 160 and 165. Here it will come. 150 again in the first class. 151 again in the first class. Children, please take care that for every 4 tally marks, the 5th tally mark comes as a slanting line like this. Now children, you can complete this table on your own and then count the number of tally marks and write the frequency in front. So you will observe that for the class interval 150 to 155, frequency is 12. For 155 to 160, it is 9. For 160 to 165, it is 14. For 165 to 170, it is 10. And for 170 to 175, it is 5. Children, you can add all the frequencies and check whether the total comes out to be equal to 50. This helps us in detecting any error. Children, can you conclude anything about the heights of students from this table? Yes. Maximum number of students have height in 160 to 165 centimeter range. Minimum number of students have height in 170 to 175 centimeter range. You can see that more than 50% of students, that is more than 25 students, have height shorter than 165 centimeter. Children, I have a question for you. 30 children were asked about the number of hours they watched TV programs in the previous week. The results were found as follows. Children, you will make a group frequency distribution table for this data, taking class width 5 and one of the class intervals as 5 to 10. What do you observe from this data? How many children watch television for 15 or more hours a week? Children, do this yourself. So children, so far we have done how we can collect data. We have also done how we can present data in grouped or ungrouped frequency distribution table. Now we are going to learn how to represent this data graphically. Children, there are three ways of representing data graphically, that is with the help of bar graphs, with the help of histograms, that is of equal width as well as of unequal width, and third is with the help of frequency polygons. Children, we have already done bar graphs and histograms in lower classes. Let us quickly recapitulate them with a few examples. A survey was conducted asking 50 people about their favorite ice cream flavor. The information collected is as follows. So you can see that different flavors have different frequencies. Chocolate is having 15, vanilla 10, strawberry 10, mint chocolate 9 and others 6. Now let us represent this graphically. Children, on the horizontal axis we can take flavor and we can take frequency along the vertical axis. For the vertical axis, we need to take a scale according to the information given or according to the frequency. Since frequency is ranging from 6 to 15, we can take a unit of 2. That is, after every box, 2 changes. So after first box there is 2, then 4, then 6, then 8, then 10, then 12, then 14, then 16, then 18 and then 20. So here on the horizontal axis we are going to represent different flavors. For this we are going to leave the first box vacant. The second box we will draw till a height of 15 units. So here this is representing the frequency of chocolate flavor. Then we leave one box in between and then again we are going to draw a rectangle whose height is 10 and width is 1 unit only. Then again we leave 1 unit, that is 1 box, and draw a rectangle representing strawberry whose height will be 10 units. Then leave a box vacant. Then mint chocolate flavor will be represented by this rectangle having a height of 9 units. Then leave 1 box. Then others flavor will be represented by this rectangle whose height is 6 units. So children, this is how we draw the bar graph for the given information. So children, can you tell me which flavor is the most liked flavor? Yes, it is chocolate flavor. Which two flavors are liked equally by people? They are vanilla and strawberry. So children, let us learn how to draw a histogram. This is also just like a bar graph, but it is used for continuous class intervals. For example, let us represent the data shown by this question with the help of a histogram. Children, this table shows the heights of students in centimeters and we have formed various groups for it. And then this is the frequency or the number of students which lie in that particular group. In order to represent this data on a graph paper, we are going to take the horizontal axis to represent heights of students and the vertical axis will represent the frequency or the number of students. Now children, you can clearly see that the class interval is of 5 cm. So here we are going to take a scale in such a way that along the horizontal axis every 1 unit is equal to 5 cm. But here, since we are moving directly from 0 to 150, in order to show this jump we are going to draw a jagged line or a kink. Now the number of students or the frequency is going to be represented by the vertical axis. And you know that the range of this frequency is nearly till 14. So you can take a scale of 2 students, that is every 1 unit will represent 2 units. Children, here the areas of the rectangles erected are proportional to the corresponding frequencies. Since here widths are all equal, so we can say that lengths of rectangles are proportional to the frequencies. That is why we draw lengths according to frequency. Now let us look at another question. Children, 100 surnames were randomly picked up from an employee list of a company and a frequency distribution of the number of letters in the English alphabet in the surnames was found as follows. So you can see that the number of letters, they are grouped as 1 to 4, 4 to 6, 6 to 8, 8 to 12 and 12 to 20. and the number of surnames that fall in these groups are 6, 30, 44, 16 and 4. Children, let us try to draw a histogram for this. Clearly, horizontal axis will be taken to represent the number of letters and vertical axis will be taken to represent the number of surnames. Since the number of letters are represented by the groups of 1 to 4, 4 to 6, 6 to 8, 8 to 12 and 12 to 20, we can take a scale of 1 unit is equal to 2 letters on horizontal axis. So here we have taken 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Since the number of surnames, the frequency is ranging from 4 to 44, let us take a scale of 5 units on vertical axis. So the numbers are 5, 10, 15, 20, 25, 30, 35, 40 and 45. Let us draw the rectangles. Since the first group is 1 to 4 and its frequency is 6, so the rectangle will be drawn like this. It will start from 1, it will have a height or length of 6 units and it will end at 4. Next 4 to 6, it will be represented with a bar or a rectangle of height 30 units. Next, like this, a height of 44 units. Next, a height of 16 units. And next will be height of 4 units. But this graph is not representing the data correctly. We know that area of a rectangle should be proportional to the frequency of that class. Here it is showing that frequency of class 8 to 12 is more than frequency of 4 to 6, which is not true. So we need to make certain modifications in the length of rectangles so that areas are again proportional to the frequencies. For this, there is a methodology. First of all, select the class interval which has a minimum class size. For example, in this question, minimum class size is 2. Now modify the length of the rectangles to be proportionate to the class size 2, like this. So here, we already had number of letters in the form of groups. This is the frequency column. Width of the class we will write by subtracting the upper class limit and the lower class limit. So the width of the first class is 3, second is 2, third is 2, fourth is 4 and fifth is 8. To get the new length of the rectangle, we will calculate like this. We will divide the frequency by the width of the class into the width of the smallest class, that is 2. So we get 4. For the next class, we get 30 upon 2 into 2, that is 30. Next, 44 upon 2 into 2, that is 44. Then 16 upon 4 into 2, 8. And 4 upon 8 into 2 is equal to 1. So now we will draw the graph according to the new length of the rectangles for these class intervals. For example, here 1 to 4 class interval will have a height of 4. 4 to 6, it will have a height of 30. 6 to 8 will have a height of 44. 8 to 12 will now have a height of 8 units. And 12 to 20, it will have a height of 1 units. So children, now you can see that this graph seems more appropriate. Can you tell me in which class interval maximum number of surnames lie? Yes, it is 6 to 8. So children, this was how you draw histogram for class intervals of equal width as well as class intervals of unequal width. Children, now we will learn another way of representing data, that is frequency polygon. Just look at the histogram that we made earlier. Children, in this histogram, join the midpoints of the upper sides of the adjacent rectangles. Let us name them as B, C, D, E and F. After joining them, we get a figure B, C, D, E, F. To complete the polygon, we assume that there is a class interval 145 to 150 having 0 frequency and class interval 175 to 180 having 0 frequency, and mark their midpoints as A and G. Now join AB and FG. You get a polygon ABCDEFG. This is called a frequency polygon. But can we draw a frequency polygon independently without drawing histograms? Yes, let us see how. For this, we require to find midpoints of class intervals called class marks. Children, for any class interval, class marks is equal to upper limit plus lower limit divided by 2. Let us learn this with the help of an example. Here this table gives the distribution of students of a section according to the marks obtained by them. So you are given the marks in various class intervals 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. And the frequency of these class intervals are 3, 9, 17, 12 and 9. Children, first of all, we will find the class marks for each interval. For the first interval, the class marks will be 0 plus 10 divided by 2. That is lower limit plus upper limit divided by 2. So we get 5. For the second class interval, class marks is 10 plus 20 divided by 2. That is 15. For the third class interval, it will be 20 plus 30 by 2. That is 25. Next, it is 30 plus 40 by 2. That is 35. And next, it will be 40 plus 50 divided by 2. That is 45. So children, this is how we got the class marks for each of the class intervals. Now instead of plotting the class intervals, we are going to plot class marks along the x-axis and frequency along the y-axis. We know that our class marks are ranging from 5 to 45. So we can take a scale in such a way that 1 unit is equal to 10 marks. So here we have 10, 20, 30, 40, 50, 60, 70 and so on. Our frequency is ranging from 3 to 17. So we can have a scale of 2 units along y-axis. That is, the number of students will change by 2 after every unit. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 and so on. So what will be our first point? How will we plot this? Look at 5 on the x-axis. Here it is 5. And we want to plot 3 on the y-axis. So the first point is 5, 3. Here it is. We have marked it as point A. Next point is 15, 9. So 15 lies between 10 and 20. Here it is 15. And 9 on y-axis means it is midway between 8 and 10. So here we get the point B, 15, 9. Next point would be 25, 17. 25 on x-axis means midway between 20 and 30. And 17 on y-axis is middle point between 16 and 18. So here the intersection of these two lines gives us the point C, that is 25, 17. What is the next point? The next point is 35, 12. 35, here it is between 30 and 40 and 12 on y-axis, here this point. So the point D gives us 35 and 12. What is the next point? Next point we have to plot as 45, 9. So 45 on x-axis and 9 on y-axis. So this gives us the point E, 45, 9. Children, join these with the help of line segments. Does this give us a frequency polygon? No. Frequency polygon has to be a closed figure. So we assume that there is another class interval, which is the next one, 50 to 60, and we assume that it has frequency 0. Its class marks will be obviously 55, that is the midpoint of 50 and 60. So we have to plot 55, 0. Here the point F gives 55, 0. Again we have to assume that there is a class interval which is before 0 to 10, that is minus 10 to 0. Its class marks will be minus 5 and we have to assume that its frequency is 0. So the point that we have to plot is minus 5, 0. Here it is and we name it as point O. Now join O and A and here join E and F. Now we have got a closed polygon. This is called a frequency polygon for the marks obtained by students of section A. Now suppose you are also given distribution of section B according to marks obtained by them. Can you make the frequency polygon for section B on the same graph paper? Yes, of course. This is the information that is given for section B. For the class interval 0 to 10, the frequency is 5. For class interval 10 to 20, the frequency is 19. For class interval 20 to 30, the frequency is 15. For class interval 30 to 40, the frequency is 10. And for 40 to 50, the frequency is 1. Children, first of all, we will find the class marks of each class interval. Just like we did earlier, these will be the class marks of the class intervals. Now let us plot the points corresponding to the class marks on x-axis and frequency on y-axis. Now the first point will be 5, 5. That is, we have to look at 5 on x-axis and 5 on y-axis. So children, here we get the point P, which corresponds to 5 on x-axis and 5 on y-axis. Next point is 15, 19. That is 15 on x-axis and 19 on y-axis. So we get point Q. Next is 25, 15. 25 on x-axis, 15 on y-axis, that is point R. Next is 35, 10. That is 35 on x-axis, 10 on y-axis, we get point S. Next will be point T, which is 45, 1. 45 on x-axis and 1 on y-axis. But children, this is not a closed polygon. So again we have to assume that there is another class interval after 40 to 50. Say it is 50 to 60. Clearly its class marks will be 55 and we have to assume that its frequency is 0. So let us plot the point 55, 0. But this is already plotted and we have named it as point F. Similarly, we have to assume that there is a class interval before 0 to 10 and its class marks will be -5. And we have to assume its frequency is 0. When we plot this point, it is again point O. So let us join O, P, Q, R, S, T, F. This is the required frequency polygon for team B. So these two lines represent the frequency polygons. Children, frequency polygons are used when the data is continuous and very large. It is very useful for comparing two different sets of data of the same nature. Children, I have a question for you. Draw a frequency polygon for the following data which shows the runs scored by a team for different number of balls. If the number of balls are arranged in class intervals like 1 to 6, 7 to 12, 13 to 18 and so on till 55 to 60, the runs scored by team are 2, 1, 8, 9, 4, 5, 6, 10, 6 and 2. Children, we have to make a frequency polygon for this, but if you note carefully, these class intervals are not continuous. So it is very difficult to draw a frequency polygon for such a class distribution. So what do? We have to make these class intervals continuous first. There is a way of it. Now if you look at the upper limit of the first class interval, it is 6. Lower limit of next class interval is 7. What is the difference between the two? It is 1. That is 7 minus 6 is equal to 1. Now divided by 2, you get it equal to 0.5. Now children, you increase the upper limit of every class interval by 0.5 and decrease the lower limit of every class interval by 0.5. So you get a class interval distribution like this: 0.5 to 6.5, 6.5 to 12.5, 12.5 to 18.5 and so on till 54.5 to 60.5. Now clearly this distribution is continuous. So now it will be easier for you to make the frequency polygon. So please try it yourself. So children, this was part 1 of grade 9 chapter 14 statistics. Here we studied what is the different kind of data like primary data and secondary data. We also studied how we can organize data in a group frequency distribution table as well as ungrouped frequency distribution table. We also studied how we can represent data in the form of graphs, that is bar graphs, histograms as well as frequency polygons. We'll meet in part 2 where we will study how we can analyze and interpret data, that is we will use mean, median and mode. Till then, goodbye, keep practicing. Thank you.